Hello, everybody. Welcome back to another video on solving quadratic equations. So when we look at quadratic equations, we're looking at any equation in the form of ax squared plus bx plus c equals to 0. Now, these are referred to as second degree equations. And the reason we refer to them as second degree equations is because the exponents, the highest or the largest exponent here is 2, second degree equation. So since these are second degree equations, when you're looking at the solutions, you can find a max of 2 solutions to these equations. We'll talk about these solutions some more. Now, ax squared is considered the quadratic term. And then bx is considered the linear term. Now, additionally, we have the c value, which is considered the constant term. And then the last thing I do need to say is this. The a value is important. It's critical, actually. We refer to it as the leading coefficient. So whenever I mention the leading coefficient, we're looking at the number in front of the term with the highest power. So once again, a is called the leading coefficient. So back to the fact that when we talk about these equations, we're looking at a maximum of 2 solutions. Now, other terms that mean solutions include roots, zeros. Also, if we were to graph these on the xy plane, they would intersect the x-axis. So therefore, the x-intercepts would also be referred to as a solution. So basically, wherever a graph intersects the x-axis, that represents a solution. Pretty much, we're looking at 3 types of solutions. 3 types of solutions. So a quadratic could have 1 solution. And if it's got 1 solution, it's going to intersect the x-axis just once. So you might see something like this. Here, let me do a quick graph for you. You might see a graph like this, where the graph is intersecting the x-axis just once. Now, if the problem has, let's say, 2 solutions, on the other hand, let me use a different color here, okay? If it's got 2 solutions, this means that if you were to go ahead and sketch the graph of this, the graph would intersect the x-axis twice. Now, wherever the graph intersects the x-axis, that represents a solution. So this could be 1 solution, and this could represent the other solution. So 2 solutions. That's the second option. And then last but not least, guys, there's a possibility that these graphs may not intersect the x-axis at all. So which means if the graph is not intersecting the x-axis, there's no solution. However, we need to emphasize the fact that there's no real solutions. So if it's not a real solution, what do we call it? Imaginary. I need to talk to you guys about imaginary solutions. So if the graph is drawn where it's never intersecting the x-axis, that means that that quadratic has no real solutions. Rather, it would have imaginary solutions. So when you sketch the graph, guys, the graph might look something like this. So if it looks like this, it's never intersecting the x-axis. There's no real roots, no real solutions. And so essentially, you could say the solutions are imaginary. You can't graph imaginary numbers, so that's why it's not intersecting the x-axis, okay? So anyways, what are some of the ways to solve quadratics? So here's a synopsis of the different methods we can use to solve quadratics. Number 1, the easiest one, factoring. Now, factoring, guys, listen, is easy, but it only solves some of the quadratics. Not all quadratic equations are factorable. Number two, we've got the square root property, and the square root property works really well. But be careful with the square root property, it only solves some of them. You've got completing the square for number three. Now, I am going to be talking about completing the square, but I am not going to emphasize it. I just want you to get a preview of completing the square. So if you don't completely get it, that's okay. Everybody's favorite method, of course, is the quadratic formula, which we'll discuss in details. And then I am going to add this one on here, although I've already talked about it, and that is the graphing method. And so essentially, in the last screen, I talked about the different ways based on the solution that the graph could affect the x-axis. So based on that, basically, all you have to do is look at the graph. If the graph is intersecting the x-axis, determine how many times it's intersecting the x-axis, and that will determine whether or not it has a solution or it doesn't have a solution. So if it intersects it once, it's got a solution. If it intersects the x-axis twice, then it's got two solutions. If it never intersects the x-axis, then it has no real, emphasis on real, solutions, but rather it has imaginary solutions. All right, so I am going to go into detail about each method, starting off with the factoring technique. Here, let me use a Roman numeral here. Roman numeral 1 has to do with factoring. Now, when it comes to factoring, guys, the first step to factoring to solve a quadratic equation is to isolate the quadratic. That just means you need to set the quadratic equal to 0. Number 2, once you have the quadratic equal to 0, you want to factor the quadratic. Remember, guys, this is the factoring technique, so this means that whatever problem that you get that says to solve by factoring, it can be factored. So if you cannot factor it, it may mean that you might not be able to do factoring, but that doesn't mean that it's not factorable. Number 3, now we're going to use the zero product property to solve. And the zero product property essentially says this: if A times B is equal to 0, then that means either A will equal to 0 or B must equal to 0. One of them must be 0. So the question is, what's the value that will make the equation equal to 0? Now, as we go through the examples, you'll see how easy this method is. And keep in mind, factoring doesn't solve every single quadratic. It only solves some of them, okay? So guys, here goes the examples. And I'll try to do 2-3 examples under each topic because we'll cover additional examples in class. So here's number 1. Now, for number 1, I've got x squared plus 11x is equal to a negative 24. Now, first and foremost, you should notice this is not isolated. So first, you have to isolate the quadratic by adding the 24 to both sides, or just take the negative 24, move it over to the left side. Once you move it over to the left side, you're going to now factor. Split up x squared into x times x. What are 2 factors of 24? That adds up to 11. Find 2 numbers that multiply to give you 24. Here, let me write this down for you guys. Multiply to give you 24, but add to give you 11. So those 2 values would be positive 8, positive 3. All right, so you got your factors. Now you are to take each factor, set it equal to 0, and solve. Because remember, either the first one is 0, the second one is 0. One of them must be 0. And when you multiply by 0, what do you get? 0. So your goal is to figure what value will make each one of these parentheses 0. So guys, we're going to solve now. I'm doing this the long way, but I'll show you the shortcut in a minute. So here, One of the solutions turns out to be -8. The other one turns out to be a -3. So when you set this up in set notation, because that's how you're going to have to input it into the computer, you do -8, comma, -3. And that's it. Typically, the set notation will be given to you. All you have to do is input those values in there, and they do not have to be in numerical order. Now, here's the shortcut to this, guys. Once you have these factors over here, all you're simply asking yourself is this: what number plus 8 makes this parenthesis 0? -8 plus 8 makes that parenthesis 0. So therefore, one of the solutions would be -8. So you go to the second parenthesis, same thing. What value of x plus 3 would make this parenthesis equal out to 0? That would be a -3. -3 plus 3 is 0. Yeah, and 0 times anything is 0. So you can eyeball these factors once you have them and figure out the solution to the equation. Now, here comes example number 2. For example number 2, I've got x squared minus 25 is equal to 0. If you guys recall from our conversations about factoring, this is called a difference of squares. Now, when you're factoring a difference of squares, guys, it factors into two binomials, and those two binomials are referred to as conjugates. So x squared is x times x, and the -25 is going to factor into -5 times +5. So you got your two factors. Now just eyeball it, ask the question, what value of x minus 5 makes the first parenthesis 0? What number minus 5 makes that parenthesis 0? So that would be +5. For the other one, same thing. What number plus 5 makes the parenthesis 0? What value plus 5 makes the parenthesis 0? That would be a -5. And so when you write your solution set would be 5, comma, -5. And just like that, you're done. Remember, guys, the goal is to find the value or values that makes the equation equal out to 0. So if I were to put 5, take 5 and substitute that into the original problem, and I were to square it, 5 squared is 25. Is 25 minus 5 minus 25 equal to 0? Absolutely. So you're done with the problem. Now, here's another one, guys. Be careful with this one right here. Number 3, it's x squared minus 3x equals to 0. Some of you may even be able to look at this and say, oh, I know the answer. What number can I plug in for x to make this equal to 0? 0, and you're done. No, 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 no. Because this is a quadratic equation, it's a second-degree equation, always be on the lookout for at most 2 solutions. So this one is another problem that can be factored. And the way you factor this one, guys, is that it has a GCF. So you need to factor out the GCF out of the 2 terms. So once you factor out the GCF out of x squared, that leaves you with x. If you factor it out of -3x, that leaves you with a -3. So now you have your factored form. If you cannot see your 2 factors, here they are, x, and then the other one is x minus 3. So now you want to set each one equal to 0. Look at that. That's already solved. X is equal to 0. That's one of the solutions. You figured that out already. And take the other one, set it equal to 0, and also solve this to get x equals to 3. So there's your 2 solutions, 0, 3, and just like that, we're done. So factoring is an easy method. However, it only works for some of these quadratics. It will not solve every single quadratic for you, okay? So guys, here comes the next method, method number 2. And method number 2 involves the square root property. And for the square root property, I haven't been keeping track of my time. I need to keep track of my time to see how long this video is. I don't want to make it too long now, okay? So the square root property, guys, if you have any quadratic in the form of x squared equals to c, or perhaps x plus a squared is equal to some constant, these are the perfect candidate for the square root property. So the square root property works best for these type of equations. Now, the first step in using the square root property to solve quadratics is to, number 1, isolate the square term, the exponential term. Now, once you have this isolated, as in get it by itself, number 2, you're going to take the square root or the inverse, the square root, this is what the square root looks like, of both sides. So you're doing the inverse of both sides. Now, once you take the square root of both sides, here's where you need to be super careful. You got to remember this one, guys, okay? Whenever you take the square root of both sides, you're going to end up with a compound solution, as in x will equal to plus or minus. Yes, guys, two solutions, plus or minus. You got to remember this, okay? And then step 3 is to go ahead and solve for x. Okay. Now, again, I am only going to do a few examples here, maybe 2 or 3. So pay careful attention as I go through this, okay? So here comes the first example. So example number 1, x squared minus 25 equals to 0. And I'm doing this one first because it was in the previous method I talked about, which was factoring. So on this one, I'm going to try to isolate the square term by adding 25 to both sides. So I get x squared is equal to 25. Now, once I have the x squared term isolated, I'm going to take the square root of both sides. Taking the square root of both sides. And guys, here's what you have to remember. You must remember this. This is critical, okay? Because it does affect how well you do these problems on the computer. If you don't input both answers, the computer will mark it wrong. So in the case of this one right here, guys, remember, whenever you take the square root of both sides, you end up with a compound solutions, 2 answers, as in 1 positive, 1 negative, okay? And then the square root of 25 is 5. And just like that, we're done. Now, I do believe in Math Excel, you have a plus or minus symbol on the tools palette. So if you have that, that's awesome. Just go ahead and use that whenever you're inputting these type of answers, the plus or minus. So you don't have to write it out as 5, negative 5. All right, so let me go ahead and clear this one out. Now, here's the next one, guys. Let me see here. Okay, 2x squared is equal to 18. Now, on this one right here, I'm going to divide both sides by 2. So I get x squared is equal to 9. And then take the square root of both sides. So I get x is equal to, remember, compound solution, plus or minus 3. Bam, we're done. Okay. Now, here comes the next one. Third one. Okay, now this you have to be careful with. Super careful. Because we got a binomial squared is equal to, I'm going to make this one 16. Okay? So you got to be careful with this. So x plus 5 squared is the square term. So you got to get rid of that power. So do the inverse by taking the square root of both sides. Now remember, when you take the square root of both sides, you're going to end up with compound solutions, plus or minus 4. So now what you have to realize is that you have 2 equations. X plus 5 equals to 4, positive 4, or x plus 5 is equal to negative 4. Now, you could have continued this as a compound equation, but for most people, it's easier to just go ahead and break this up into 2 separate equations and solve it out. So as you can tell, one of the solutions is negative 1, and then the other one is going to end up being a negative 9. And there you go. Now, for those of you who are curious, ooh, Ms. Alcira, how can I do this in one single step? Here's how you do it. You take the 5, move it over. So that would become x equals to negative 5 plus or minus 4. So what you have here is basically representing 2 solutions. So you do the sum, you do the difference. So negative 5 plus 4, that's the sum. So that gives you a negative 1. And then negative 5 minus 4 gives you a negative 9. That's the difference. So you still get the same answer. It really doesn't matter. Okay, so that was the square root property. Okay, so I think I'm gonna pause here. No, let me go ahead and finish this with completing the square. Do I want to do completing the square right now? Yeah, I think I'm gonna pause here and then I will come back to completing the square and the quadratic formula. So guys, until next time, that's it. I feel like I made this video too short, but I want it to be short, okay? So until next time, bye everybody.